Ever wondered how an electromagnet works? How a seemingly ordinary coil of wire can suddenly attract metal objects with a force that can be switched on and off? To understand this, we'll have to journey back in time to the early 19th century. Our story begins in the year 1820 with Danish scientist Hans Christian Ørsted. Ørsted discovered that electric currents create magnetic fields. This was a groundbreaking revelation for its time. That same year, French scientist André-Marie Ampère demonstrated that iron could be magnetized by inserting it into an electrically fed solenoid, a coil of wire. Just 4 years later, in 1824, British scientist William Sturgeon invented the electromagnet. His first creation was a horseshoe-shaped piece of iron wrapped with about 18 turns of bare copper wire. When a current passed through the coil, the iron became magnetized and attracted other pieces of iron. When the current stopped, it lost its magnetization. Sturgeon's invention, although it weighed just 7 ounces, could lift 9 pounds when connected to a single-cell power supply. But Sturgeon's magnets were weak, limited by the uninsulated wire he used, which could only be wrapped in a single spaced-out layer around the core. A breakthrough came in the 1830s when U.S. scientist Joseph Henry, using wire insulated by silk thread, managed to wind multiple layers of wire on cores. This created powerful magnets with thousands of turns of wire, including one that could support over 2,000 pounds. This marked the beginning of the wide-scale use of electromagnets, particularly in telegraph sounders. The mystery of how ferromagnetic cores work was first proposed by French physicist Pierre-Ernest Weiss in 1906. The detailed modern quantum mechanical theory of ferromagnetism was then worked out in the 1920s by Werner Heisenberg, Lev Landau, and Felix Bloch, among others. So, what are the key points to remember about electromagnets? They're a type of magnet where an electric current produces a magnetic field, usually consisting of wire wound into a coil. The magnetic field can be quickly changed by controlling the amount of electric current in the winding, a distinct advantage over a permanent magnet. However, unlike a permanent magnet, an electromagnet requires a continuous supply of current to maintain the magnetic field. These versatile devices are employed in a multitude of applications, from motors and generators to MRI machines and magnetic separation equipment. They're even used in industry for picking up and moving heavy iron objects. So, the next time you see an electromagnet in action, remember the centuries of scientific discovery and innovation that make it possible. From Ørsted's initial discovery to Sturgeon's first practical electromagnet, to the detailed theories of Weiss and Heisenberg, each step has contributed to our understanding and use of this fascinating technology.